I got a B plus.
I got a C.
See? Oh.
Yeah.
You're the one that was always giving us the answers.
Yeah, like how did that happen?
Yeah, I don't know. When I started the exams, middle of this, in I haven't even got to up to 15 questions, and my internet just messed me up. So I was stressed out
Oh.
taking the rest of the exams.
You got a
Sorry
better
about
plan
that.
to get internet?
Yeah, I think we still have some exams as well.
All right. Well, that was. I'm glad it didn't take 4 hours, huh?
Yeah, 38 questions.
38 questions. It took me 2 hours.
That's about where I was because I started around 8 and got done like around 10.
Man, I tell you, one of the best things I did to help me on that quiz was use an Excel sheet.
Oh, that's what I did too. I just built my formula in a sheet, but I had a buddy review some of the process with me because especially the SAT questions, dude, that thing used to freak me out. I'm like, what are they asking about? So he's done it before and he reviewed it before I finish up and want to take the test, and that helped a ton.
Yeah. So
Oh,
I'm kind of stumbled with this week assignments. Oh, my other classes are quite busy for me. I'm taking 14 credits and
oh,
Oh, you're busy, man. 14 credits. That's busy.
it's easy.
It's busy.
and are you working too, Bartolo?
Yeah. Yes. So it's quite. I
Hmm?
think I have one spreadsheet analysis class is kind of pulling my leg down.
Question analysis. Oh, is that B212?
B215.
B215. Okay. Do they still? Oh yeah, B215. That's right. I did B215 not long ago. Dude, there are a lot of YouTube videos that will help you with like formulas and stuff. Like I mean, I went to a class, but
Yeah.
I often learn a lot from YouTube and just Google and just familiarize yourself with it. That's what helped me. I will YouTube and see what, because it's mostly project based. At least when I did it back then, it was, get this project done and then you go to class and do another
Yeah.
mini project in class. But anyways, but it
Yeah.
is a tough class.
What class is that? What's the name of it?
It's Excel
Spreadsheet analysis.
spreadsheet analysis. So you just do a bunch of. They start with like basic, Excel manipulation, and then you go all the way to you touch VBA just a little bit, and VBA is kind of like programming an Excel sheet. For an engineer, you'll probably notice it's kind of like coding. So you code a little bit, and then you use all the functions that you learned through the semester to create project, and those projects are based on what the criteria is. This is what it was back then. Like I don't know
Yeah,
what they're doing
it's still the
now.
same thing. It's still the same. Still the same. Yeah.
Mm.
And it's quite involving. You have to spend a lot of time working on that.
Mm.
But anyway, I'm
Cool.
still,
Okay.
yeah.
Should we? I wonder what the quiz will be like today. Should we jump into it?
Yeah, let's do it.
Mm. 21 question. What is up with these long quizzes?
21. Yeah, so fun. So, I'm going to pull up. All right, got the lesson up. I've been trying to study beforehand, of course. So which hypothesis involves equality?
Um, present.
All right, so the involves equality.
Let me see here. Should have given this a little more time last night.
No,
I think it's the null hypothesis.
I think it's null too.
Yeah.
Just looking that up.
It is in lesson 9.
Yes, lesson 9. It is the null hypothesis. So that's the first one. All right, the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Remember that the p-value is the probability. Okay. When computing the p-value, which hypothesis do you assume to be true?
I think that one is the null hypothesis.
Yes, it is.
Okay.
Yeah, I just took notes on that. Suppose the null hypothesis is h naught mu equals 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
So the alternative should be greater than 10. No? The alternative, let me see. Let me go back to the
I'm not sure. I'm still looking.
Yeah, it should be greater than. It's right around it's right below where the question number 3 answer was. So HO mu is 140, and then right down HA means should be greater than 140 pounds. So that's answer B.
So what do you think it is? Which one do you think it is?
It's HA mu should be greater than 10. So let me show my screen real quick. Yeah, share. So right here. So you see right here? So H naught mu was 140. In contrast, another positive will write the alternative hypothesis. This is typically the statement that the researcher suspect is an actual truth. In our case, we suspect that the mean weight of 4 is greater than 140. So HA mu is greater than 40. So then the question is here.
All right.
Sorry. Wait a second. I didn't read this right. It says for a two-tailed test. So it'll be good to revisit this.
Okay, well, I'm thinking the only two-tailed test. Yeah, the only two-tailed test is the not equal to.
Oh. Okay.
So we'll go for that.
Okay.
Which of the following represents the alternative hypothesis for a left-tailed test?
Wait, sorry, quick question. So number 5, where did we end up with? Was my answer correct? Because I'm kind of doubting my answer now.
I think it's not equal to the third one.
Oh, not equal. Okay. Yeah, because after reading the question again, I started thinking. Cool. Number 6.
So now we're looking for a left-tailed test. A left-tailed, one-tailed test on left side. Left tailed, that would be the first one. The way I think of it is that the arrow, the less than, is pointing to the left. It looks like an arrow to the left. That's how you know it's a left tailed test.
Okay.
Alternative hypothesis for a right tailed test. That would be the second one, greater than 10.
So question 6 is greater than 10?
Question 6 is less than 10.
Okay.
Question 7 is greater than 10.
Okay.
Remember that we determine, okay, number 8 now. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or A. This information to answer the next 2 questions.
Which relationship will result in a
Failing to reject the null hypothesis.
P is less than. Yeah, oh, 1 second. Double check that. We can say that is more than.
We're on question 8.
Okay.
Question 8 is p-value greater than A. And question 9 is p-value less than A.
I'm sure my company is policy exactly higher than this. So option 2 and 3 on number 10. I'm thinking. I think the second option. Well, the second and third kind of. I think the second option on number 10. What do you guys think?
Well, I think that they're concerned that the true mean is actually higher than 15 months.
So I'm good at that test.
Which of the following would be the appropriate alternative hypothesis?
I was in Singapore for the summer and then this fall.
Why'd you go be at work physically?
Oh, there?
Yeah.
Was
it internship or you just okay?
And then I was off track, so.
So I'm thinking. I think it should be the second one.
He's doing graphic design for some company.
You think so?
I think it makes 70.
Yeah, that's what I'm thinking.
Yeah, they're not going to get
all right.
And get out. It's really
I'll go for that.
Credit lay on a 80 grand over there.
Yeah.
Like
Number 11, which of the following would be the appropriate null hypothesis?
a lot of opportunities there though. So it's like a hit or miss. And I was like, dude, your little man is growing up so fast.
Yeah. He's 6 months old now.
Holy cow. Time-wise.
This is my last semester. I'm doing my internship at the hospital right now.
That is
But I was gonna go print out some resumes.
It's gotta.
I'm going. I didn't think tired, but I'm like,
It's okay. You're handsome now. But no one will notice. You're not wearing a tie.
The appropriate null hypothesis.
I got this from my dad.
Okay.
My computer was flickering and I started to do a lot of backup and I didn't have big one enough where I didn't have this.
The null hypothesis, it's equal to the
right? But I got this.
So I think I'm thinking of the first one. What do you think?
All right. Well, good luck.
All right, good to see you. I'm sorry, guys. Sorry about that. Wait, what did we get to number 10?
Number 10, I think
Was
we
the
said,
second option, right?
yeah,
And what number are you guys on now?
number 11.
11. We think it's the first one.
And oh, we're back to these again. They're trying to company randomness to the n equal product limit calculation.
Here's the distribution of the sample is normal. That's a good assumption.
Yeah. Is this a good assumption? Yeah, I think it is because the
Sample size is large.
yeah, n equal 40 claims.
All right.
What theorem or law justify answer? So this is the central limit, right? Because I think I wrote down a lot of large numbers if I did. The central limit is if the n is large enough, distribution of sample mean will be. Wait, is this so large and central get me confused all the time? Let's carefully visit that. Don't listen to what I just said. Let's carefully visit that.
Yeah.
I'll go to the book actually.
Let's see.
Okay, yeah, I think it's central limit theorem.
Okay. Just thought I'd double check that.
All right, 14. Which of the following is the test statistic as defined in this lesson?
Go back here.
That would be Z.
Okay.
Yeah, the test statistic, yeah, the Z.
It's down in section 4.2 in the textbook.
Oh, okay.
All right, the historical mean of sales rates and store manager suspects the average of increase. She sets up a hypothesis test with the hypotheses.
Mm. Hypothesis is 50. 2 years, level of confidence.
What is the score associated with this test? All right.
Oh, so we're just calculating z-score as usual, right? Let's look at the formula here. I don't see anything different.
Nobody call.
Yeah.
All right, so we here. Okay.
Random sample of 36 sales receipts.
Simulations for 150. 150. Six is the size. 0. 36 received from a student computer Mexico. 144. That's 9.
40. 50.
My z-score came up to minus 9, minus 0.9.
Minus 0.9.
Let me see.
How do you do it? I just wanted to trying to. Can you share your screen?
I did the old. 1 second. This is just using the old formula that we have. So right here, the observed value that I used was the 144. That's the oh dang it. What is this? Okay, so 144 is the observer. Wait a second, this is the sample mean. So sorry, I used the sample mean as the observed value, so that was wrong.
All right.
Yeah, so this is where I went wrong. What did you guys use for your observed value?
What formula are you using? Where is it at in the book?
I'm using this right here. Sample mean minus this minus the mean divided by the standard deviation and it's the population size or the sample size.
Where does the
But what I haven't considered is the level of significance. This thing right here, that is not in my formula, so that could be thrown. Yeah, okay.
that might not be applied in that one. It might be
That's what-
applied in the next question.
That's true. So So then I think it's correct because our mean there is 150, and then our observed value is 144, which is the sample mean, the X bar, and the standard deviation is 40. The sample size is 36. So I'm getting minus 0.900. How did you guys do yours?
All right. Let me finish my formula here, and then I'll tell you.
Oh, okay. Let's go.
We need to go the minus divided by square root.
Daddy, I still want the phone.
Divided by the sample size. Our n is 36. All right, our n is 36. Nice the mean. Standard deviation. Divided by square root. E58. Okay, so I got the answer of negative 0.9, which is what you got, Hugo, right?
Yeah. And we're doing 3 decimal places. But Bartholomew, do you have a different number, or do you feel like?
It's not that I'm working on it, DC.
Huh?
It's not that I'm working on it.
Oh, okay. So, like, do we wait or do we continue?
Continue.
Okay. I mean, we only got 6 more, so it's.
Yeah.
Hmm.
There's a
It's a
p-value
p-value.
associated with the z-score from the previous question.
Oh, geez. P-value. That is extreme.
I'll believe in saying this.
Okay, so I think we gotta use the apply on this one. Gotta go look at that apply somewhere. Oh, I should have saved this as a link. I mean, we constantly use this thing. I should just save a link that I can use. Let me check in chapter 3, I think. But I did use it, yeah. Probability apply, where the devil are you?
There you go. And the value z.
Yeah, that's what I also guess. It's negative 0.9.
Okay.
Okay. That's good.
Great. Okay, so we plug that into the applet. Now what do? We
1 second. And then you look for the extra. I'm trying to get an app. I haven't saved it as one of my favorite yet, so I always have to go look for it, which is probably my last time looking for it. I have to save it now. There it is. Sweet.
Do you got a 0.36?
Yeah.
0.3681. That's what you got?
That's what I got. I'm not sure if that's what they're looking for.
Oh, 1 second. I think we have to go diff. So if it's a two-tail test, was it a two-tail test or one-tail test? Because if it's two-tail, then we'll use both end of it, which the answer that Bartholomew suggested would be right. But if it's one tail, then I think we'll use the negative side of the line, or like the left side of the probability app. Does that make sense?
So this is a less than. They want to know the, okay, less than, equal to, equals, and then less than. Equals, and then less than. This is a one-tailed test on the left side.
Okay, then we'll only focus on the left side of the app, which would be 0.1841 or 0.184. That's what I'm thinking. You guys think it out. If you're thinking another way, I think we can reason on it. But
That's my best guess, yeah. The value.
So yeah. 0.1?
0.184. Because
okay.
they left test.
Okay.
Single tail test to the left.
all right. What inference would you make about a null hypothesis for this problem? Ooh.
I'm not sure how to determine how to determine that.
I think I have to go visit our bulk again. 1 second, I'll run through it.
Okay, so the null hypothesis is inherently true, and we gather evidence against it. So what is the hypothesis? That the historical mean of sales was equal to 150. The hypothesis is that it was actually minus 150.
So meaning it fails to reject the null hypothesis.
Oh, and the level of significance. I think that this is where the level of significance, the 0.05, will come in handy, right?
I believe so. Yeah, that's what I'm thinking.
So, because if the p-value is higher than the level of significance, oh, this because we're making inference now. So okay, it will come in handy. Reject. I'll fail to reject if Wait, didn't the p-value have to be higher than the z-score in order for you to reject it? Okay, never mind. Never mind. That was me going a silly ballad there. Just ignore that.
All right. We have insufficient evidence that the true population is less than 150. What's our probability applet at? So we're less than
I think
15%.
what I'm understanding is if the p-value is lower than a level of significance, you reject. If it's higher, then you fail to reject. That's what I'm understanding.
If it's less than the level of significance.
Yeah, then you reject. If it's greater, then you fail to reject. That should be in lesson 9.
Okay. How do we decide that the p-value is small enough to reject or not? We need a way to determine if there's enough evidence to reject. I'm reading 4.4. That's where it talks about it.
That's what I'm looking at.
Let me use a second. P-value. Okay, if the p-value is less than a, we reject the null hypothesis.
Okay, and in this case, our p-value higher than a, which is 0.05. So we fail to reject. That's how I understood it. What do you guys think?
Yeah. P-value is less than, right? It said if the p-value is less than a.
Yeah,
Yeah.
if it's less than a, you reject. If it's greater than a, you fail to reject. Isn't that?
Yeah.
Am I reading?
Oh, I understood it. So, yeah, so 17 would be failed to reject the null hypothesis.
Okay.
And then what is your conclusion for this problem on number 18? The answer would be the third one.
Yeah, that's sufficient evidence that the truth. That's right. Bartholomew, are you with us?
Yes.
All right.
Okay.
19, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when null hypothesis is true? One. Whenever we reject a true null hypothesis, we say that a type 1 error was committed. We did not reject it, so this would be type 2.
Okay.
Yeah.
So we should have decided that instead of using a level. Oh, so we're still on the same scenario giving up there.
We're using the level of significance.
We
will use 8.01, which of the following is true. Okay, so our p-type was calculated at 0.184.
The probability type 2 is
higher than the level of significance. So if it's higher, then
I think number 2, the probability of a type 2 error will increase because it's just moving the same direction. 0.01 is less than 0.05. Does that make sense?
Yeah, so it's on the opposite side of the p-value now.
No. So if in our previous answer, because we failed to reject, since the p-value was higher than the a, down here the p-value is still higher than a because a just got lowered. that make sense?
Yeah.
So
Um,
if our answer in 19 is type 2, the probability of type 2 happening here would just increase. If that makes sense.
I think I agree with you.
Okay, yeah. Yeah, makes sense. 0.185 lowered, so 0.3. Okay, yeah, it's still on the same side. I misinterpreted that.
Okay.
All right, so 21, last one. If A equals 0.05, compute the probability of committing a type 1 error.
Yeah. Are we just gonna use our z-score? Oh, so wait. If we still have the things, we still have the app on minus 0.9, then shouldn't it be anything higher than our current? Oh, let me share my screen real quick. That will make a lot of sense than what I'm trying to rumble here. Right here, because this is what we're using for our p-value. What does that mean? Anything higher than this would be the probability of type 1, since this is the probability of type 2.
I would think so, yeah.
0.816 then. But Bartholomew, are you thinking something else? Like that was just
Yes.
a suggestion.
That is what I'm also thinking about. As this thing. So I
Okay.
think let's plug in our number and see.
Okay.
Oh man, here we go. Are we good? Any last question before we
No,
hit blast off?
no, go ahead.
All right, I'm going right now since I got ahead of class, and then if there's anything we got wrong, I will just give you guys a heads up before I run.
All right.
Oh, okay. We were wrong on the last one. We were wrong on number 19, which makes sense. If we're wrong on the last one, then we're wrong on number 19. So number 19 and number 20, we were wrong on it. And then number 10, we got number 10 wrong. So 10, 19, 20. Yeah, that's it. So 10, 19, and 20, we got wrong.
What about 21?
21. Oh, sorry, let me go by there real quick. Yeah, we got 21 wrong. 10, 19, 20, 21, since they're kind of connected together.
Okay.
Can I resubmit this thing? Because sometimes we get this done, and then I run to class, and then after, I don't know if I can resubmit. Like, does it say anything about it in the syllabus? I should probably reread that.
Resubmitting what?
Like resubmitting this quiz. Can I resubmit it after we're done with group meeting, or no?
Yeah, you can resubmit it. But you still have two options. Options to submit it, and you have done the first one. So I don't think there's anything. I haven't read anything about that.
Oh, man, you may have been failing it, or I've been scoring low on these quizzes. I thought we couldn't resubmit. So whenever we get done here, I'm like, I'm just gonna fail or like get a lower grade. I didn't know we could resubmit, but
You can resubmit it. Yeah.
Okay. Yeah, those are the ones that I saw on. Thanks again, guys. I'm gonna run to class, but
okay.
See you guys next week. Have a great weekend.
All right, you too. All right, Bartholomew. So 19, 20, and 21.
Yes.
Let's go up to 10. You can start there. Oh, 10. Equal. It's not. It's not. Not equal. So greater than or less than. Okay, I think that number 10 is greater than 1500.
Yeah, that's what I'm also looking at. I think, yeah.
All right, so number 19 we put in type 2, so that has to be type 1 then. Researcher decided that instead of using a level of significance of 0.05, use 0.01. Type 1, which is not type 2 error for number 20. Not the first or second, I know that.
The number 20?
On number 20, it's not the first or second. Experiments will be more scientifically valid.
Level of significance. I was trying to read through.
Compute probability of finding a type 1 error down to the decimal places. Now, did on number 21, did you put 3 decimal places or 2?
I think it was 3.
No, if you look at it, it says 2.
Okay, so it should be 0.82.
Yep, 0.2. Okay.
Yeah.
Number 20, I think, is the third one. Number 21, I think, is 0.82. You want to submit it and see what you get?
Okay. Should I submit mine?
Yeah.
Okay. Yeah, question 10, I got it right. Question 20, I got it wrong.
Which
21, I got it wrong. 20, I got it wrong. And 21, I got it wrong. So,
You got number, did you say just 20 and 21 were wrong?
Yes.
Okay. Oh, man. Well, I don't know what the answer to 21 is then.
Yeah.
But do you have another submission?
No, I'm trying to. Let me see. I can. Coming, let me resubmit this thing and see.
So you're out of submissions. Huh?
Yeah, so that was my first submission. So I wanted to save and
Okay.
I can see the question 20. I don't know what is.
I don't know how to do number 21. The probability of committing a type 1 error. Hypothesis testing. The probability of a type 1 error in hypothesis testing is predetermined by the significance level. Okay, so we got the z-score. We take the z. What's the square root of our z-score?
So now, question 20, thinking of either it's the type, the probability of type 1 error will increase.
Number 20. No, that's
so that means that the experiment is will be more sufficiently valid.
Yep. I happen to know that the first one is wrong because I've taken this test before. And I got that one wrong because I answered the first one.
Okay.
But now I don't know how to calculate the for number 21. I don't know. I'll have to work on it. I'll email it to you if I figure it out, okay?
Okay.
All right, see you later.
Bye.